Okay, this video is for 4.2, which is properties of logarithms, and the homework for 4.1 is going to be due on Monday, and we'll go over it on Monday, and then we'll go over the homework for 4.2 as well on Monday. So this section is about properties of logs, and we're just going to go over parts of logs. So a log, oh, I need to make sure that this pen is on. Okay, so there's log base b of a equals x. So b is called the base. So this would be log base b. A is called the argument. That's just what the term is called. And then x is the exponent. And then if we rewrite it into exponential form, we would have b to the x equals a. So b is the base, x is obviously the exponent, and then a is the argument. So that's the term for it. Next is the common log and the natural log. So the common log is log base 10. And what you normally see on like a scientific calculator is just log. And so log base 10 and 10 to the x are inverse operations of each other. Those would undo each other. And then the natural log is ln. This is log base e. So ln and, well, I guess it would be, ln and then e to the x. Those are opposites of each other. E is approximately equal to 2.7, but your calculator would do the exact amount. If you are calculating like e to the third or something, you would want to make sure that you're not approximating it with 2.7, but that's what it is. It's approximately 2.7. So that's just a review of log and natural log. We already talked about the change of base property, but in this section, we're going to be using the change of base property where we're changing the base of the numerator and the denominator. And what we've done before is if you have like log base 3 of 7 or something, you could do log of 7 over log of 3. And this makes it so that you can type it in your calculator because that would be log base 10 over log base 10. But you could also do ln of 7 over ln of 3, and your calculator could do that as well. Or you don't have to do one of those. You could do log base 3 or log base 7. As long as these numbers are the same, then it doesn't matter what number you choose. We just choose log base 10 or ln to type it into a scientific calculator. So now we're going to do these problems. So how would you approximate this to a decimal? Well, we would use the change of base formula. So you could do log of 100 over log of 8. And like I said, you could also do ln of 100 over ln of 8. And I don't have that decimal right off the top of my head. So if we do log of 100 over log of 8, this would be approximately 2.21. Okay, and then this one, we would rewrite it as log of x plus 88 over log of 6. And that's just how you would rewrite it. Okay, next, these are some properties of logs. So right here, you have b to the log base b, that log base b of x. So those just simplify to 1. And then you have x equals x. Or you could have log base b of b to the x. And so they just cancel. They just simplify to 1. And so you're just left with that. So that's one property that you'll need to remember. And then the next one is the exponent property. So whatever this exponent is, if you have log base b of x to the m exponent comes down in front. So we're going to solve this by using those properties. And the first thing that we're going to do is we're going to log both sides. So we have log of 5 to the 3x equals log of 9. And what that does is it makes it so this 3x can come down in front. And then we can divide by 3 log 5. So x is log 9 over 3 log 5. Okay, that's one way that you could do it. Another way you could do it is you could do log base 5 on both sides. So if we have log base 5 of 5 to the 3x equals log base 5 of 9, then this would come down in front. You'd have 3x, and then log base 5 of 5, that just simplifies to 1. And then we could divide by 3 on both sides. So we could say log base 5 of 9 over 3. I'm going to rewrite that as 1/3 times log base 5 of 9 so that it's easier to see the change of base formula. So I'm going to say 1/3, maybe 1/3 times log of 9 over log of 5. And if we put that all together, that would be log of 9 over 3 log of 5. So we get to the same answer. It just looks a little different. Okay, so those were 2 different ways of solving it. Whichever one makes more sense to you. Next, we have e to the negative 57,300k equals 1/2. So how do we undo e? The opposite of e to the x is ln. Sorry, they're not equal. They're inverse operations of each other. So if we ln both sides, ln of e to the negative 57300k equals ln of 1/2. This exponent comes down in front, and ln of e just simplifies to 1. So we have negative 57,300k equals ln of 1/2, and we divide by this number. So k is ln of 1/2 over negative 57,300. If it says solve exactly, then you should have a log or an ln in your answer. Same with this one. Solve exactly means that we would And with this, we wouldn't approximate it to a decimal. Okay, the next one, we have 10 to the 2x minus 6 equals 8 to the 4x minus 5. So what we're going to do is we're going to log both sides because we don't want those exponents. So we have log of 10 to the 2x minus 6 equals log of 8 to the 4x minus 5. We're going to bring that down. Okay, the nice thing about this is if we do log base 10 of 10, that just cancels out. So we have 2x minus 6 equals, and we're going to bring this down, 4x minus 5 times log of 8. Log of 8 doesn't cancel because the base is 10, so we can't cancel those out. What we can do is distribute this. So on this side, nothing changes. And then we have 4x log of 8 minus 5 log of 8. We want everything with an x on the same side so that we can factor the x out and get x by itself. So I'm going to add 6 over here, and I'm going to subtract 4x log of 8 minus 4x log of 8. So we have 2x minus 4x log 8 equals 6 minus 5 log 8. And then we have these x's here. We can factor that out, and we have 2 minus 4 log 8 equals 6 minus 5 log 8. And then we divide on both sides. This process is pretty common. It's not, I feel like sometimes it's not the first thing you think of, but if you can manage to get everything with the variable you're looking for, so in this case we have the x's, that's what we're looking for, right? So if you can manage to get everything with that same variable on the same side, then you can factor it out and divide. So we've done that before, so hopefully that didn't feel too confusing, but this would be your answer. So one recommendation that I have for a problem like this where you have these two exponents, I don't know why this highlighter isn't working. Oh, it was just trying to highlight text. Okay, so if you have two different bases for your exponents, I would recommend doing log base, 10 or 8 so that it gets rid of one of them. You could just do log or ln on both sides, but then your answer would be like, it would have a log here too, like log base 10 and log of 10. So if you can do log base whatever, then that could be beneficial. Okay, next is the sum and difference properties of logarithms. So basically, if inside here, if this is multiplying, you can separate it and do a plus. If it's dividing, you can separate it with a minus. You can write it as two separate logs. So let's expand this. So inside of the parentheses, we have multiplication. So I'm going to say ln of x squared plus ln of y to the fourth. So this plus right here this multiplication turns into a plus when we write it out as two separate ones. This is a sum. And then the exponents can come in in front. So expanding this would be 2 ln x plus 4 ln y. Okay, and then the other one, this one is dividing. So when we write this out separately, we have log base 5 of the numerator minus log base 5 of the denominator. And that's as simple as it gets. Okay, let's do a line. If this was log base 5 of x plus 4 and the square was outside, then you could bring it down. But this is just, that's not what was written. So this is it. This is our final answer. But even if it was like in here, if this was an exponent up here, then we would write 2 down there. Okay, so just some reviewing of properties of logarithms. This is rewriting a log as an exponent. Log base b of 1 equals 0. So if this argument, that's what that term is, that part is called, if it's ever 1, then the log of 1 is 0. And then log base b of b is 1. We've gone over that. These ones we just reviewed as well. Those cancel, and you're just left with x. If you have log base b of u equals log base b of v, then u equals v. So if you have log base 3 of u and log base 3 of v, then that means that u has to equal v. This is the change of base formula. This is where you can move the exponent down and it goes in front. And then this is the sum and difference that we just talked about. So this one is sum, this is difference. So now we're going to put those to use and we're going to expand a couple of expressions. So I'd like you to pause the video and try this because this is a skill that is important to have, but you're expanding this out as much as you can. So pause this, come back and see how you did. So I'm going to add in a little multiplication sign right there because we have x to the 4th times the square root of x minus 6. So the first thing I'm going to do is I'm going to say log base 4 of x to the 4th plus log base 4 of the square root of x minus 6. And that's the first way that you can start expanding this. I'm going to move this 4 down in front. So we have 4 log base 4 of x. And then this one, technically, we could write as x minus 6 to the 1/2. That's rewriting it in a fractional exponent instead of a radical. And then that 1/2 can go down in front. So that would be plus 1/2 log base 4 of x minus 6. And that's as simple as it can get. So rewriting this from radical form to a fractional exponent is something that you might not have seen it when you did this by yourself, but that's something to remember. And then this needs to stay in parentheses because it's log base 4 of the whole thing, not just log base 4 of x and then minus 6. So if you wrote 1/2 log base 4 of x minus 6, this means something different than with the parentheses right here. So got to make sure that you write it in parentheses. And I'm just going to erase that so it's not confusing. Okay, go ahead and try this one. Pause the video and then come back. So the first thing, we have our whole argument raised to the 5th power. So I'm going to move that 5 down in front. And I'm going to do 5 times log base 3 of 3 to the 6th over x to the 4th, y to the 4th. Okay, and then the next thing we can do, this is dividing, so we can write that as a difference. So again, I'm going to keep the 5 in the front. So we have log base 3 of 3 to the 6th minus log base 3 of x to the 4th, y to the 4th. This 6 can come down in front. So we would have 6 log base 3 of 3 minus log base 3 of x to the 4th, y to the 4th. Log base 3 of 3 simplifies to 1. So I'm just going to have 5. And also I'm going to distribute this in right now. Boop and boop. So this would actually just be 30 minus 5 log base 3 of x to the 4th, y to the 4th. And now right here, this is invisible multiplication, right? We don't see an actual like multiplication sign, but they're multiplying. So we can write this as a sum. So this would be 30 minus 5 log base 3 of x to the 4th. I'm actually going to be minus 5 times log base 3 x to the 4th plus log base 3 y to the 4th. And then these can come down, these exponents. So this would be 30 minus 5 times 4 log base 3 of x plus 4 log base 3 of y. And then I'm going to distribute that 5 in, that minus 5. So it would be minus 20 log base 3 of x. And then it would be minus 20 log base 3 of y when we distribute that negative with the 5. Okay, you can also be asked to take an expanded logarithm and write it back into a single logarithm. And that would look like this. So we have log of 7x cubed plus log of 6x squared. This plus means that we can combine them in multiplication. So that'd be 7x cubed times 6x squared. And we can just multiply those together. So that would be log of 42x to the 5th. Okay, the next one, we have a number in front of the ln for each of these. So we can put those back as exponents. You'd have ln x to the 4th minus ln of y to the 4th minus ln of z to the 6th. Now, what we did on the last one, if you noticed, we had minus here and minus here. That's what we have right here. So this is actually ln of x to the 4th minus ln y to the 4th plus ln z to the 6th, because that negative distributes. So this would be ln of, this right here is division. It means we're going to have a fraction. And then this one tells us that we're going to be multiplying. So x to the 4th is in the numerator, and then y to the 4th times z to the 6th would be in the denominator. And so it's ln of that whole fraction. Okay. Now we're going to write this as a single log. So in order to make this into a single log, we need to have log base 4 of something and then log base 4 of something. So I'm going to write log base 4 of x minus 3 times log base 4 of 4. So then we have log base 4 in both places. The 3, I'm going to write it up here. Sorry, so I guess the log base 4 is going to go after. So we have log base 4 of x minus log base 4 of 4 cubed. The minus means that we can write this as a fraction. So it would be log base 4 of x over 4 cubed. 4 cubed is 64. So this would be log base 4 of x over 64. Okay, our last topic is extraneous solutions. So an extraneous solution is where you solve this algebraically and then you get a solution. You have to check to make sure that it's actually in the domain of a log, because the way that solving logs works, sometimes you can get things that aren't in the domain. So let's solve this first, and then we'll look at the solutions and I'll explain more about how to tell if it's extraneous. So right here, this plus means that we can write this as a single log. So we're going to say log base 2 of x times x minus 1. That would be x squared minus x. And then we can rewrite this. So if I raise both sides to, if I do 2 to the power of log base 2 and then 2 to the power of 1 on the other side, then that would cancel. And we have x squared minus x. And then over here we have 2 to the first power, which is just 2. Sorry, I have a tickle in my throat. So then to solve this, we're going to subtract 2 on both sides. And then this is a quadratic, so we can factor it into x minus 2, x plus 1. And the solutions would be 2 or negative 1. So now what you do is you plug it in and you see if you get an extraneous solution. So if we plug in 2, if x equals 2, we get log base 2 of 2 plus log base 2 of 2 minus 1. So that's log base 2 of 2 plus log base 2 of 1. And that all checks out. That's fine. But then if we try x equals negative 1, log base 2 of negative 1, if you type that in a calculator, which, oh, you know what? I can do the graphing calculator. Oh, that's not what I wanted. Okay, here we go. The graphing calculator of Desmos can change the base of a log. So I'm going to go here and just show you what it says. So if we do log base 2 of negative 1, it's undefined. Oh, negative 1, sorry, negative 1. It's undefined. So if you remember, so because this is undefined, which means x equals negative 1 is an extraneous solution. So I'm going to remind you what the graph of a log looks like. So it looks like this. There's an asymptote on the y-axis if there's no transformations. So that means that if you get any number that is 0 or less, 0 is also an extraneous solution because there's an asymptote. You can never have an x value of 0 that has a y value. So when you're doing logs, if you get 0 or less, any negative numbers or 0, then that would be considered extraneous when you plug it back in, because we plugged it into log base 2 of that. So that means that anything, if x was less than or equal to 0, to plug it in, that would be extraneous. Okay, the last problem is this one. So I'd like you to pause the video and solve it the same way that we just did. So put it together as one log and then solve it, and then see what solutions you get and if either of them are extraneous. Okay, so we have log base 4 of something plus log base 4 of something else. So we can put those together as a single log with multiplication. So it would be x minus 2 times x minus 14 equals 3. And then in order to, well, I'll multiply those together first, because if it's log base 4, then we would want to raise each side. We would do 4 to the log base 4 of that equals 4 to the power of 3. So we would have x minus 2 times x minus 14 equals 64. 4 cubed is 64. And then when you multiply this out, this would be x squared minus 16x plus 28 equals 64. When you do the foiling. And then in order to factor it or solve a quadratic, it has to be equal to 0. So we're going to subtract 64 on both sides. We have x squared minus 16x minus 36 equals 0. You can factor that if you think about what multiplies to negative 36 and adds to negative 16. Think about it for a second. It would be negative 18 and positive 2. Those would be your the factors. That's how you factor it. So then x equals 18 and x equals negative 2. So it's not necessarily a given that because this is negative, it doesn't necessarily mean that it has to be extraneous. You still have to plug it in and see in the equation if it would be extraneous. So we would have log base 4 of 18 minus 2, and that's fine because that's a positive number. And then log base 4 of 18 minus 14, which is also fine. So x equals 18 is a valid solution. And then we do log base 4 of negative 2 minus 2, and that would be not good because that would be log base 4 of negative 4, which is not allowed. So I'm going to put x equals negative 2 is an extraneous solution. Okay, and that's it. So we're going to briefly go over this on Monday, but because of the way the schedule is, we just don't have time to push everything back a day, or else we'll lose a day to review for the final at the end. So try the homework. It looks like this. You're going to write this as a single log, and then you'll solve this logarithmic equation. Okay, see you Monday.